Hi, I'm Andy, and this is my lesson on accessing array elements in Java. In this lesson, I'll show you how to access and change the elements in an array. Then I'll explain two common exceptions encountered when working with arrays and how to avoid them. Let's get started. Let's start by making a simple integer array of numbers. Remember, arrays are objects. However, they are a special type of object. Unlike normal objects, we don't access them using methods. Instead, arrays have their own unique syntax for accessing their elements. For example, suppose I wanted to print this element's value. Notice it's the third element in the array and therefore located at index 2. To access an element within an array, we put the name of the array and then two square brackets containing that element's index. Let's run our code and make sure that worked. We can also use this bracket syntax to change array elements. Try to predict what our array will look like after this line of code executes. So this code copies the value from index 2 into index 3. Index 2's value does not change. Okay, so that's how you access array elements no matter what type of array you're dealing with. For example, suppose we had a string array like this. And then suppose I wanted to print out the first letter in the last string. There's a couple of ways to do that. First, we could store that string reference in a string variable. And in these brackets here, we could put a 2, but to make our code more flexible, let's put an expression that works no matter how big this string array is. The last element in any array is at an index that is one less than the array's length. So we'll put this expression as the array's index we'd like to access. Then we can print the first letter in that string using the substring method. Remember, the first character in a string is at index 0. Now let's run our code and make sure it works. Good. Okay, let's see another way to do this. Remember, the elements in an object array are references to objects, not the objects themselves. So this right here is a reference to a string object. So instead of making a string variable, we can invoke the substring method directly on the array element, like this. Good, so our code still works. Okay, let's go back to our original integer array. Now check out this code. First, we'll declare another integer array and set it equal to the first integer array. Then we'll change the first element in more nums. Lastly, let's print the first element for both nums and more nums and see what happened. Surprisingly, it looks like both arrays ended up changing. Here's why. When this line of code executed, the nums array was created like this. Now this line of code executes. This is the line we want to make sure we understand fully. Remember, the assignment operator copies the thing on the right into the variable on the left. The thing on the right here is not an array. It's a reference to an array, meaning it holds a memory address that helps the Java virtual machine locate the actual array. It is that address that gets copied into more nums. When that happens, we have two array references, but they both reference just one actual array. Since we have more than one reference to this object, we call these reference variables aliases. So this line of code changed an element in that one array. Thus, when we printed out the element using either alias, we got the same exact output in the console. Okay, let's go back to our original nums array and try to add another element to it. As you can see, our array currently consists of 4 numbers. If we were to add a 5th number, it would be placed at index 4. Let's try to do that. It looks like we got an ArrayIndexOutOfBoundsException. That's because we tried to access an array slot that doesn't exist. This is a very common exception in Java. Notice that the exception's error message helps you identify the problem by telling you which index you were trying to access when the exception occurred. Since that didn't work, you're probably wondering, how do you increase the size of the array so you can add more elements to it? The answer is, you simply can't. In Java, the size of an array is immutable. Once you create the array, its contents can be changed, but its length cannot. Okay, before we go, this is a good time to introduce another very common exception you'll see in Java. It's called a NullPointerException. Here's one situation in which you'll get that exception. Suppose we have a string array of length 3 called words. Now we want to print the first letter in the first string in that array. To do so, we would just use the substring method, like this. Let's see what happens when we run this code. So there's our NullPointerException. Notice that the exception's error message tells us what line of code was executing when the exception occurred. In this case, we're being told that this code caused the problem. A null pointer exception occurs when you ask a null pointer to execute a method. A null pointer is a reference variable that contains the value null, instead of the address to an actual object. This should make sense. You can't ask a reference variable to have its object execute a method when it's not yet connected to any object. Let's see how that happened in this case. When this line of code executed, a string array was created and its address was stored in the reference variable called words. Notice that words is not a null pointer. It is a reference to an actual object, this array right here. However, remember that object arrays do not contain objects. They contain references to objects. So this bit of code right here did not create any string objects. It made the container, the array, to hold the references to 3 string objects. Like all object references, the object references in an array have a default value of null. This means that all the references in our words array are null pointers. That's why this line of code produced the null pointer exception. To fix this problem, we simply need to create a string object and then use the assignment operator to store its memory address in slot number 0 of our array. We don't have to, but let's also fill in the other 2 array slots with references to actual string objects. We'll make those string objects using the shortcut method. Now our code should work fine. Good, so since the reference at index 0 is no longer a null pointer, we eliminated that null pointer exception. And that wraps up this lesson on accessing array elements in Java. I'm Andy. Thanks for watching and coding with me today.